Everything we've done up to this point in terms of models, in terms of real-world equations, has come from the idea that we have one nice input-output relationship between one variable and another, between one value and another. But in reality, that's often not quite enough. There's often more subtlety, more detail, more things that we can and should consider if we want to get a full picture of what's going on. If we want to fully understand a situation, it's often not enough to just think two-dimensionally. We need to get more involved. We need to think of more pieces that can go in. For example, if we want to talk about the amount of money that a company is making, we usually need to do that in terms of two pieces. The amount that they spend, their costs, and the amount that they make, their revenue. Where we can talk about modeling in terms of revenue and cost functions, where if we have a nice linear relationship that they make, say, $1.55 per thing they produce, then we'd have R is 1.55x. And if we say that it costs $350 to get started, that's their fixed cost. That's what they have to pay no matter how much they make, no matter how much they work with. And then another 85 cents per item to make it, they would have cost 0.85x plus 350. And then from there, we could think about things like their break-even point. That is, the amount of production they make where their cost equals their revenue. And that's the point at which they start making money. Or if you want to think of it in a different way, the point at which, they stop losing money. Where if we want to think of that graphically, we could understand that in terms of how that appears, that's going to end up being the intersection, the point where our two lines meet for our revenue and our cost. We're trying to figure out what that point is, where that point lands, means solving a system of equations, where in particular we are solving a system of linear equations, so this is sometimes said to be solving a linear system. And what we're seeing in this class is just barely scratching the surface with this topic. There's actually a lot more that goes into solving systems of linear equations that you may see a little bit of if you go on and do the extra credit stuff in Chapter 6, and you will definitely see more of in pre-calculus and linear algebra if you go further with that. But right now, we're starting with basic cases, with things like the linear system here, 3x minus y equals 7, and 2x plus 3y equals 1. We have those two equations there, which aren't quite presented as functions of x or y, and we want to figure out the values x, y that satisfy both of them. That is, we want to figure out where those two lines are going to happen to meet. And in particular, with that there, we could say that the point 2, -1 is a solution. And the reason why we can say that is because if we go into our system and we pull out our parts, plug in our values, we would get that 3 times 2 minus -1 minus a -1, excuse me, I'm thinking my double negatives too quickly here, but we stick these together and what we'll end up with is 7, so our first equation is satisfied. Meanwhile, for our second, we would have 2 times 2 plus 3 times -1, so we'd have 4 minus 3, or 1. So this satisfies both equations. This is a valid solution. On the other hand, something like 0, -7 would not be a solution for this linear system, because if we were to plug this in here, we would have something like 3 times 0 minus a -7, which would end up being +7, so that's good for our first one. But in the second case, we would have 2 times 0 plus 3 times -7, which would end up being a -21 here, but more importantly, is not equal to 1. So our first equation is satisfied, our second isn't. This is a perfectly valid point for that first line, but a completely invalid one for the second, because again, here what we're looking for is that intersection. And we'll see later that when we're talking about these linear things, when we're talking about finding our solutions and classifying them for linear sets of equations, in particular two variable linear equations like this, you're going to usually have either that single point or parallel lines, so no solutions, or we're going to have the same line, which means everything is a solution because they're the same line, but we'll talk more about that later. For now, what we're going to do is look at our two main methods for being able to solve equations of this form. We're going to look at what's called substitution, as well as addition, which you may know just as well by the name elimination.